Hello everybody, welcome to this new lecture. In this lecture I will talk about fluid APIs. I think that there are really few lectures in the world on that, so that will be really interesting to see this. What is this tool? And in particular we will look at the case for the class definition in Pharo as a concrete example. The goals of this lecture is to think about methods with a large number of parameters, to show you what is in fact a fluid API and what are the properties, and to think a bit more modular, and also to study a really concrete case that is the class definition in Pharo. So for example, the docking bar class has a method with 1, 2, 3, 4, 5, 6 parameters, which it's too much in fact. And what you see is that it is invoked, for example, in these other methods with default values because the user does not know exactly what is the value that it should pass, or if it is optional. So in the case it is optional, he will put nil. So what you see with this example is that first there are really too many parameters, but in addition, it forces users to specify all the parameters. And when you don't know, you put nil. It goes against the idea of limiting the propagation of nil, as you saw in the avoid nil lecture. So we can do better. In addition, imagine that you would like to say, oh, you know, as a developer, I don't need this, or my client do not need this optional argument. So I want to propose in the API of my class a new method. That should be okay, but it means that suddenly you will have to provide all this variation, because I remove action, I have one with action, I have with key text, and here this is easy because we remove the optional argument at the end and we go from left to right, right to left, sorry. But what if we want to change the order? What if the optional argument is in the middle? It's a total mess from that perspective. We will have far too many methods and a combinatorial explosion. So let's study what is a fluid API. So a fluid API, this is basically, instead of having mandatory parameters like here, we will cut these methods into separated methods. And like that, the user, so this expression will become like that. We said, okay, instead of having the methods add, icon, help, and by the way, in the Java syntax, this method, this is add, icon, help, W, A, age. We will just say, okay, we just want to have x dot add W, x dot icon A. So we turn these single methods into multiple methods that are autonomous. And this way, we can, as a user, use them in the different way. So this means that I could call add, icon, and help, or I can call icon and add. Or I can also just say, oh, I don't need to change anything. I just want to specify the help string. So if we analyze this solution, we don't need to pass all the default values around. There is no combinatorial explosion. So this means that from the developer of the class, you don't have to think about all the possible variation that maybe your user would like to have. You just specify your messages or the methods that are needed and no more. From the user perspective, you can focus on the message that you need. You will just specify, oh, I need that method, and we'll send this message. Of course, it requires that you have a good and modular initialization, because this means that the arguments that are optional, they should be well initialized. And you should pay attention if you have dependencies between parameters, then in that case, maybe you will have a method. For example, if I take back the example, you could have add icon, for example, because maybe the add and the icon, they are linked together into an initialization, but this means that you can split, you can still split your long your method with long parameters into different variation. So it has the Thread API is really nice. And now we will see a concrete case. The question that we got with Pharo, this was, okay, how do we support the evolution of class definitions? Because in Pharo, we have multiple class definitions, and they have to change because over the years, we introduce package, we introduce multiple formats like ephemerons or not, and we also introduce the point that we have now, we don't have instance variable anymore, we have first class instance variable. And we want to do that without having a parameter explosion. So let's look at it. So Pharo is originally inspired by Smalltalk 80. And in Smalltalk 80, one of the way to create a class, so for example, this is a class with a variable part. The instance have a variable part. We will use this message, variable subclass, instance variable names, So this is already 5 parameters. That's already too much. And the funny thing is that I always joke this definition because I said, oh, you know, you have to pass default value. Instead of not passing the value, you have to pass it. And here we have to pass an empty string. And I was always worried about that. I said, this is completely, if this is empty, why do we care? So first, up to Pharo 9, we removed one of the parameters. You see, you don't see it anymore because it is not frequent that people use shared pools. This is a lecture that you will see in the future. Shared pools are handy, but when you don't use them, why do I have to specify an empty string? So in Pharo, up to Pharo 9, in fact, we just introduce a new version where you have package instead of category and no pool here. So we remove it. So you see, this is already, this is another version of the class definition with 4 parameters. And then we had to change the variable subclass also to have the 4 version variation. And like that, I could continue endlessly. I guess that we have 40 different methods to create a class definition. And this is insane. So we wanted to really have modern class definition because we have package, tag, slot. We have various formats like word, byte, double byte, variable, index. And then we have new format like ephemerons because they are special things for a weak structure. And we faced this. We said, okay, we cannot continue like that. So we decided to use a Thread API. So this means that using optional argument and to be able to control the mandatory parameters and only specify the necessary parameters. Like that, we have a syntax that is extensible. And what you will see is that it needs a builder. And sometimes you need optional default values. So let's look at it. So in Pharo 10 and Pharo 11, now we define a class like that. We said, okay, I would like a subclass of the class arrayed collection. And here we have separated messages. Here we have 3 different messages. When we don't need to specify a layout, or when we don't want to have a tag, or when we don't want to have something, this is also correct. Here, this is a meta class. We can say, okay, this is the meta class definition. It does not have instance variable, and this is working. And you see, here, I don't specify things that are not needed. The same here, I only specify what is needed. By the way, what I want to show to you, this is that this little lesser return a class builder. And the other messages will configure it. And what we end up to have, something that is modular, compact, and extensible. So let's look at some example. So you see here, in Pharo, we have a first class instance variable that are called slots. And this is the way we said, okay, this is the slot. And then we have a specific way to define a slot inside this definition. And again, here, I don't specify anything else that what is needed. I said, okay, this is in the package. This is in the tag, because in the package, we can have some classification and the instance variable. That's it. We have also traits in Pharo. So now, in traits, I can just define a trait and if I don't need to have anything, then I don't write it. Let's step back and look a bit at what we have, because in fact, we have three kinds of messages in the class definition and the Fluid API. So first, we have the starting or creator message. In fact, it will create a kind of accumulator. So here, when we said object point, for example, this message generates a builder. The builder, this is what? This is an object that will be able to be configured via the other message. So the other message that we have here, the configuration setter, they are like slots, for example. Oh yes, I have the message slot and I can specify something. It will configure the instance of the builder with different values. Like if I can send a message tag, for example, I would say, okay, this class is in the tag total, okay. So the builder is configured. And we have a closing message. This is the one that performs the action once the arguments are passed and that the accumulator has been configured. In our definition, this is package. The package message is really saying, okay, the builder has been configured, now I can do some action. And this is what you see here. This is the creator. Oh, this guy return a builder. We configure it with multiple messages. We don't care of the order and things like that. They are optional. And this one is mandatory. It will send a message to the builder and said, please do your job now. And do your job now, in the case of class builder, will check, validate, and install, create a new class that is configured into the system. Now I want to show you that in fact this is also available in other systems, like in Seaside. Seaside is a web framework for written in Pharo. In Seaside, often people should write for each visual component, they should write a method that is called render content on, where the builder is specified. So the HTML is already the builder. This is the framework that created the builder, and you have the configuration. These messages are configuration, and the closing are these Swift messages. So on the simple case, for example, I say to the builder, oh, I want that you configure yourself to emit a header at level 3, and I want, this is the text. So when the people designed the API of Seaside, they made sure that the developer will not forget to close the builder by having this with, or this is not really closing, but this is like that. This API will create a kind of object that represent the hash3 to emit hash3 in HTML, you know, like. And here what you see, this is another case, for example, where they said, oh, they have again this configuration. They have this Fluid API that is a bit different from the class definition, but still at the end here they will have a PR or something like that with hello world. And then the width is used to control and to give a scope. So here they will do OL, for example, or the red list. They will close the OL. And here inside they will generate LE, item 1. And they use the width to make sure that the expression is closed. You see, so the width here will make sure that this guy is written. But this is the same idea. This is how can we offer an API where we can compose messages and without having extra argument and too many arguments. So what you see is that Fluid API are nice because they handle the combinatorial explosion. There is no combinatorial explosion. They handle optional argument. They will force the initialization to have good values because your object should be well initialized so that you can avoid to use a value. And then the logic, this is the builder that will have to pay attention and to be careful with the logic. And like that, the default value, they are not passed around. They are just initialized. from that perspective, this is nice because often as a client, I have no idea about if the object that I have is a good value to be initialized. So like that, this is the responsibility of the object. The builder is responsible to initialize well the things and to be cautious. The cons is that what you see is that sometimes the message order can be important, and then in that case, you will have to pay attention. Maybe you can use configuration with more than one argument and things like that. And there is really this need. Often there is this need for a closing message, because else the builder does not know. Oh, do I need to wait for an extra optional argument, or that my client will use or not? So the builder need to know. Okay, now I can proceed. I can take the configuration and do something. But this is, for us, this is really just the pay to price, and the result is much better. So as a conclusion, what you see is that in a Fluid API, you have three kinds of messages. You have, and also object from that perspective. You have the container creator, the setters that will let your client configure your creator, and a closer that will say, okay, now I can do something. So Fluid API are really nice when you have many optional exclusive parameters. So I think that they are not used enough and people don't know them. So that's why we decided to include this lecture in this MOOC.